I know we spent a lot of time on indexes, but there's one final area in terms of performance that I do want to cover, and that's kind of changing data. So we've talked a lot about selecting data efficiently and whatnot, but just wanted to talk a little bit about that. So Postgres is very good at inserts in terms of speed. The primary reason is that there's no locking going on, because whenever you're going to do an update, it requires a lock. And this is true for all relational database systems. So, but also the updates are more harmful with Postgres compared to some other relational database systems due to its multi-version concurrency control. Again, because it keeps those old rows around in the table. So if you have, a one row table, but you update that one row in that table 50 million times a day, you've just generated over that day 50 million rows in that table. So essentially, you're probably going to be bloating the table because vacuum can't keep up with the volume of data that's being updated. And again, you're probably going to have logging issues and whatnot. So Postgres does have issues with that. There's other database systems that handle it differently. So they have a separate undo or rollback area. So basically, they update that row in place. So that row in the one row table gets updated 50 million times. But those 50 million history transactions are stored in the undo or the redo. So it's hard to do a rollback with these other systems, but they're not going to create the bloat problems that Postgres does. So all that being said, when you're dealing with Postgres particularly and other relational database systems, it's usually more performant to do an insert versus an update. So if you have that case where you need to update something 50 million times, you may want to consider doing those as inserts and then deleting them later, or reach to another data store to do that. Do something in Redis that then updates something in Postgres maybe every hour with what the current value is or something. So it's just something to keep in mind when using your database system, that particularly relational databases, there's a higher penalty for updates and deletes versus just straight up inserts when modifying data.
Yeah, and deletes in most RDBs are pretty expensive operations too.
Yeah.
From performance standpoint. And they also cause some, I won't say issues, but they cause speed, I guess, in the vacuums, because when you delete a record, it's not actually deleted, it's just marked as delete, and then later on the thing has to actually expunge all that mess, and there's just more stuff to do. Also, it there's a lot of funny story about deletes that I run into.
There's always funny stories about deletes after the fact.
Yeah. But I run into this a lot, and this isn't a destruction of important data thing. This is it causes so much confusion in people who are new programmers, because they don't realize that most RDBs just tag something as deleted. And if you start inserting new records, it starts backfilling those slots. So if you do a select statement with no ordering, you'll start seeing records in all kinds of weird orders. And they're like, well, wait a minute, I just inserted these. What are they doing way up here? Well, it's because it just reused one of those delete slots. And they don't understand how that works in a database, really. They think delete means just get rid of it and then start adding stuff to the bottom. But and it's just funny because I see that a lot when I'm talking to newer programmers that haven't run into, they're just starting to get into databases and stuff. And they're like, what is going on here? These should be at the bottom. No, that's not how DBs work.
Yeah.
So
That's what they made the order clause for.
right. That's why you have to do that. Never one of the cardinal rules that I see broken a lot is never assume order in a database. You have to specifically tell it, I want the records in this order. Otherwise, you can't count on any order in a database.
Yep.
Ever. So if you're doing reporting and you're running queries that don't have an order statement, you're doing it wrong. You just are. And it's going to bite you at some point.
Well, the worst delete stories are executing a delete statement without a where clause.
Oh, God, yeah. Fortunately, I've only ever done that with staging data, never production data, but it can easily happen.
Yeah.
I've been lucky. I'm also extraordinarily careful with delete statements because...
Well, I always select exactly what I'm going to do, and then I delete the select and put delete. So there's always a where at the end.
Yeah. So...
But an even safer way to do it is to use some programmatic, like I know people that, oh, I never access the database terminal. I always use Ruby to do my query because they don't want to accidentally do something that blows away their data.
Yeah. And with deletes, that's not a bad idea. With the other stuff,
yeah.
Meh. But
yeah. Well, as long as you're only doing selects, you're not gonna.
Well, even inserts and updates, when you're doing batches of stuff, a lot of times it's much faster to batch up one query because you can do batch inserts and updates in the query itself and just send one payload and let the database take care of it. So, and that's another thing to be cognizant of with databases is every time you make a query call, every query you call has to go across the wire. So you've got, package
latency.
There.
Yeah.
It has to, the database server itself has to get hold of that query, parse it apart, figure out what it's going to do with it, with its planner, and then execute it, and then turn around and send it back to you. So the less times you can do that round trip, the much faster you're going to be, which is why N+1 queries are such a ball buster in speed issues, because I'm going to get the addresses for every person I pulled, but I pull this list of people, and then for every person I shoot off another query for the address. Well, that's not good. Pull all that stuff at one time and then do what you got to do. And, pull as little as you need. Don't do select star. You almost never need select star. It's just adding stuff to what's got to come over the wire.
Yeah, and then you're bloating your application processes too, because they're taking all that data and they don't need it.
Right. Yeah, because every Ruby object that's got to be instantiated with all that stuff, it much quicker to instantiate an object with 5 fields than 50. Especially if they're a bunch of string fields. Those are expensive. So, PSA, boys and girls, be cognizant of how many queries you're sending.
If you like this clip and want to watch another one, you can click right here. Or if you want to watch the full video, you can click here.